Yeah, so this is a simple little project that I was doing. So I work for a company called Thales that builds control systems for trains, for subway systems. So this is an S-stock train. It doesn't have the Wi-Fi antennas that we have on top of our trains. Normally we have Wi-Fi antennas here that talk Wi-Fi back to our main system. So if I just explain our system. So we have this fully automated railways. So it does everything. It sort of drives the train and everything like that. And we have every day there's small little problems that happen that they sort of clean up. But every once in a while we do have fairly major problems. And when there's a major problem, we sort of want to make sure that our management knows before the underground management knows. And you don't want your boss being phoned up by their boss and then running into a bunch of difficulties. So I really wanted a dashboard that could help me see what's going on in the railways in realish time, if that makes sense. So what I built is shown below here. So this is the dashboard I built. You can see here the clock on this on the side here. It shows the underground network. So this is sort of the Metropolitan line. And then you've got the circle line in here in the middle, Hammersmith and City and District Line, etc. And a lot of these lines I've worked on. So we're currently working on those ones I just named. So the Metropolitan line down here, going into the circle line, which goes around here. Hammersmith and City, which sort of does that. And then the District Line is this green one down here, sort of goes around there. So really what I wanted was sort of an indication of problems on these lines. I also did the Northern Line, which is this one here, the one in black, and the Jubilee Line, which is showing, it's a little bit hard to see. I think it's down here somewhere and ending up in Stratford. So if I just show a video of it. So this is a video of it going on. I think this is yesterday.
Circle line, minor delays due to damaged cables in the barking area. District line, no service between Barking and Upminster due to damaged cables in the barking area. London Underground tickets are being accepted on London buses, C2C, DLR, South Western Railway. Hammersmith and City line, no service between Liverpool Street and Barking due to damaged cables in the barking area. Severe delays on the rest of the line.
So what that was explaining was that I was sort of reading out all the announcements that Underground sends out to their website. I'm scraping that off of there. And you probably noticed the green light was flashing. Green lights were flashing because that's the District Line. And what had happened is on Sunday, I think it was, they had a bit of a fire with the high voltage systems. So it burnt a bunch of cables in this area around here. And that caused all sorts of chaos. Obviously, in the last few days, they're still trying to fix that. So it's just really good to see that and be able to know that a problem had happened, but also that it was ongoing all day long. So you could see these sorts of things. And we had another one a few days ago where a bunch of our Wi-Fi's, went down, and there's just an issue there with the power as well. Which I probably shouldn't discuss here in this forum. So I'll stop there. So that's the idea, and the whole idea is just so that I can see what's going on, but then you can also get an idea of how long it's lasting. So when things start to go wrong, I can see what's going wrong, and I can see how long it's sticking around for, so I know how important it is and whether to start investigating further. And to be clear, we don't maintain the system. We sort of supply the system, and there's separate maintainers for it and different operators. So my responsibility is if something goes very wrong, I help figure out what went wrong. And you can see here, this is a little screen here. You normally displays the time, but then here it also displays the text message as well. So you don't have to wait for the announcements, because I put on every 20 minutes going through the announcements. So why should you care? Is this audience? Well, you probably don't. You probably don't care about the tube, but you may have something else you want to you want to have a dashboard for. You may want to use some of the techniques that I use or some of the parts, or you may just want to enjoy hearing about it. So this was built with these fairy lights. So there's a 10-meter, 100-pixel fairy lights, and you sort of take this USB, hack it, you cut this off, and then you connect in the fairy lights, and they're neopixels. Unfortunately, they're fixed address neopixels. In other words, each pixel has an address to it. So if that pixel disappears, you now pixel 0 is missing. Your first pixel is actually pixel 1. So it just took a while to figure that out. And I presented something on this a few months ago. I started with 4 different strings of fairy lights, so 10 meters long. There's 100 pixels I mentioned. And I just sort of glued them into the back of this plywood that I drilled holes in. There's about 270 stations, so I drilled 270 holes and hot glued a fairy light on the back of into each hole. And you can see over here, got the pie doing the important stuff. So I bought a router to sort of make the frame. It's the first time I used a router before. It's all good fun. And I don't have a 3D printer, so I just took a piece of Perspex and bent it into shape by heating it. So that shows how it's all set up. It's got a Raspberry Pi 0W2, got that e-paper display that I've shown you. I talk via the internet to TFL Open Data, which I'll talk about in a second, and the voice is provided by Google Translate. Then I got a demultiplexer that talks the 4 strings of fairy lights. As I mentioned, they're fixed address. So if I send out an address command to light the first pixel, the same pixel would light on all different fairy light strings. So that didn't work, so I had to demultiplex them. I talked about in my last talk. So as I mentioned, I'd use the W2 for the demuxer. I used the TC4051B. These green connectors are the RS Pro, or they're also sold by Phoenix. So really good and solid connectors. These are Molex SL connectors, which are right down there. And I've used this Wave Share 3-color e-paper. So it's quite slow. So it's not really appropriate for displaying a lot, but it does work fine for this application where you're sort of displaying the time and you're updating every minute sort of thing. So the data comes from the REST interface. So that's all shown here. You sort of put in your request to the database, and it responds with JSON or XML, and you process that data. So a little bit of regular expressions and a little bit of decoding of the JSONs required. It's fairly straightforward. It takes a while to obviously understand the exact data you're getting out, but you can sort through it. I did have a little bit of problems with getting the Bluetooth working. So you can use the standard Bluetooth control application to get the pairing done and getting the trusting done, set up them initially. And then the one I'm using, which is Ultimate Ears Boom 2, you sort of have to, it disconnects every 15 minutes. So you have to, every time you want to say something via the Bluetooth speaker, I just connect, and after it's finished, I disconnect it. So I use a mPlayer to run in the user space. So you have to put into the user system D, not the root system D. So it took me quite a while to sort that out. And because I'm using SuperUserDo to run the program because of the neopixels, I end up writing a little separate program to act as UDP server to take the messages that need to be announced. Then I send that to Google Translate, which takes up to 200 characters and returns a voice file. So then you just play that via the system you set up via Bluetooth. So all that works quite well. The Transport for London site is very, very good. It's not great documentation. It'd be great if they had more examples and stuff like that, but it's okay. You can sort your way through it. It has all sorts of stuff about roads and buses and the Boris bikes and things like that. It does contain information about how far away the trains are from each station and stuff like that. I did try to get that working, but I couldn't really get it to show something sensible. I thought if I could show it with, different flashing lights at different frequencies as trains get closer, but then you've got, you have an eastbound and a westbound, and which ones you show, and how's that going to look? And didn't really seem to make much sense how I've set it up. So I've just been showing just the status of the lines. Because some of the lines share stations and share track, I sort of have to cycle through the different lines. So if it's a shared station, I'll cycle through, for example, the district line and then the circle line, and then just to show the different states of those different items. And I've tried to color match using the what NeoPixels can do as best I can, the actual line color. So what might you care about? Well, sort of these cheap fairy lights, I found that they're great. So it's about £8 for 100 pixels. It's about 10 meters. They already have diffusions. They're not, if you've ever used NeoPixels, you'll find that they're quite bright and hard in the eyes. So you're always spending time trying to diffuse them. But these are fine. They're just, it seems to be just a blob of plastic they put on it. That seems to work fine. And you can make any shape that you want, as I've shown with the map. If you're building something for highways or something like that, then you can put it into whatever shape you want.
Where did you get these lights?
Sorry?
Where did you get these lights?
Amazon.
Right, cool.
Yeah. So yeah, I can provide a link to that. So but they're not very robust. So I have lost a few pixels. So you end up, if you just one mistake with a hobby knife, and that's it for that pixel, or a whole string of pixels. So it ends up being quite frustrating. Just after I built it and just got it working, I posted on Twitter a bit about it. It immediately stopped working. I thought I'd blown everything up. Luckily, it hasn't blown up. If you've ever worked with hot glue, it's kind of hard to undo mistakes. So I'm happy for that. I do recommend Google Translate for text-to-speech. It does provide a very good sound. It is quite understandable. Other ones that I've heard, I've tried a few other ones that are free that are local. So this one you use the internet for. They just don't sound very good. So I was quite happy to find this. It is limited to 200 characters, which may not be okay for everyone's application. You can split them up into obviously different sentences, or you could do different parts to Google to get two different parts of the sentence. But I thought that's not going to be really, that won't sound that great. So yeah, so I think it was fine for my application. Yeah, it took a bit of work to get the audio working, but I'm sure everyone here can sort through it. And there's loads of different sources where you can get various APIs for weather or whatever else you're interested in. So this website there I've mentioned has over 1,400 of them listed of all sorts. So that's really it. I do have it sat here next to me, so I'm working from home. It started ticking away. And my eldest was just going out for a night and asked what the service was on. I could just look at it right away and see what the service was. I can tell them what lines are doing well, which lines are problematic, etc. So it's just a very good thing to have. And as I'm sitting there working, I can see right away that there's a problem. If it hangs around for too long, I can decide to dig into more detail and start phoning my boss, really, letting them know what's going on. So that's really it. So just a quick jaunt through that. There's more detail about about the demultiplexer and things like that in the previous video from a couple months ago. So that's it. I don't know if anyone has questions.
Richard, you mentioned some connectors.
Yeah.
Tell me more about the connectors.
Yeah. So these ones here, I'm in the UK. You buy them from RS.
What are they called?
RS components. So these ones.
Oh, those those are connectors. Oh, I know what those are. The DIN. Yeah.
Yeah, these connectors. Yeah. They're also known as Phoenix connectors.
Phoenix connectors. Yep.
Yeah.
And you can get RS stuff under Alloyed in America, Vinny.
No, I understand. Those are Phoenix connectors. They're good. They're solid. I was wondering about how you connected cables to each other.
Oh, these are
But
the
you're doing the
Molex
same.
connectors. So these Molex SL, stackable layered, I think they're called SL. They're really good. So they do have the various versions that we all need. So they have the let's go back there. Yeah, so I did a lot of research on this actually. So these Molex connectors here, these SL ones, they do have wire to wire. They also have wire to board. So there's lots of different options there. And when I was looking at the different connectors, I couldn't really find anything else that quite matched it. And one of the websites I looked at, he said, well, they really do it all. They have all the different connectors.
I've gone to these Deutsch connectors and they're incredibly expensive. DUTSCH, Deutsch. And they are unbelievably expensive, but they're more for. Find a picture.
Yeah, these ones are.
These guys here.
Oh yeah.
They're more for
Yeah.
automotive use. You know, they do these two-piece. They're a big connector like this, but they are. Let me get my spacing. They're a big connector like this, but they are more for automotive use. But they are watertight. I'm trying to figure out good solutions. That's a good one for board to board. I have to solve this problem. Incidentally, speaking of board to board, I got a question for you. Raspberry Pis seem to come with the 40 pin, the GPIO pinned on the top, but that makes no sense to me because if I want to put a fan on the top and I want to put a hat on top of it, then it really needs to be in the bottom. Has anybody you haven't experienced? Do you just desolder the connector and flip it around, or what do you all do? You know what I'm saying is that if I have a Pi like this, that little connector is sitting pointing upwards. Really, what I want is I want to make the hats. So if I want to put a fan on top of it, right, here's the device, and I want to put a fan on top of it, I'm blowing air into the hat that's above it, right, which is crazy. What I really want to do is put the device underneath and blow air off of the thing. So, you know, short of making a cable that flips it around, have you guys done this? If you just desolder the connector and then just flip it around?
So what I've done, I've had a 90-degree angle connector that goes onto the pin header. So it makes the hat go at 90 degrees to the actual board.
Yeah.
The other way is you can get header spacers that can increase the space, so you can fit a fan in underneath the hat. And that way,
then you're blowing air into the hat above it. I mean, that's fine. But just trying to see how you all do it.
Yeah,
I'm just probably going to I'm probably just going to desolder the connector and flop it around. But
the problem is that if you flip it around, it's back to front, so none of your hats are going to work.
No, I'm not reversing the order. I'm just putting the hat underneath, so it doesn't matter whether it's on top or the bottom.
So the hat will have to plug in onto the top of the hat, not the bottom of the hat.
Why are the pins different? Let's talk about that for a second. Because maybe I'm confused. So what is the difference between this device being on the top versus being on the bottom?
So as long as you keep the exact same orientation.
Yeah, the orientation changes. I'm not changing the orientation.
Yeah, then that's fine. The connector will be going into the top of the hat.
Right. Oh, that's fine. I wouldn't flip the hat. I wouldn't flip it around. I just thought it was.
So I've used a passive cooler with an extender before now. If you're not interested in cooling the hat, then that's okay.
I mean, well, the problem is it's going to sit in the dashboard of my vehicle.
Probably you need a fan.
Yeah. I like what Rich is doing with the LEDs. I've been playing with some interesting LED devices for around my volume control knob and things like that, little circle LEDs. And it's interesting programming those things to turn on and off. But I like what he did with the fairy lights for a bigger kiosk. That's an awesome idea.
there was a Spark Fun mini project I saw on Twitter a while ago with a sort of active rotary knob with a little display in the middle that was really cool.
If you haven't seen it, go look at the post I did on. I'll paste it. I found an Italian company, well, just actually 2 engineers in Italy, who are making a better version than the Spark Fun one, and I'm just very impressed with what they did. Here, I'm just going to post this, and it was relatively inexpensive. I mean, it was pretty inexpensive, but they built a nice encoder and a ring. So I did some, and I posted some code that talks to the Raspberry Pi, that talks to the ring and encoders. But it's always cool when you get good blinking lights and stuff.
Have you
going on.
looked at wearables? So how you can wear
Similar idea.
the
So we had this incident in Boston right after, let me think about this for a second. It was right after 9/11. And this young lady from MIT shows up wearing this wearable at the airport, Boston, Massachusetts. And, you know, they're known in the city of Boston for overreacting to LEDs. And so the state police attacked her and arrested her for fear of, oh my gosh, she's got a battery on her shirt. It must be a bomb. And, you know, if you look up, what was the thing they did in Boston? They had this LED thing, some crazy TV show, Aqua Hunger Team Force or something like that. They had the little LEDs for the Moonanites stuck around Boston for some kind of publicity stunt, and the SWAT team showed up and tried to disarm them because they had batteries in them. Yeah, fascinating.
The funny thing about the US is you hear all these stories and you see all these things, and then I flew domestically without realizing it with a massive screwdriver, a big Swiss Army knife, a mini Swiss Army knife, and some other type of flick knife, and they didn't even stop me.
If you remember, George Carlin did a joke about that years ago in airlines, about how they take away your knives, but they give you they give you this one so you can just slowly. Yeah, George Carlin. Very cool.
Have you looked at PWM LEDs? They're so pretty, like where you can code and change the coloring for them.
Yeah, take a look at what I did with the rings. Their assembly, the ring assembly, is an array of PWM LEDs. And it's well designed. I mean, it's these folks. It's one Italian fella and this other lady, and they call themselves Dupa, and they made some far out, like really well designed controller that you can just talk over I2C and turn on and off the different. I put a post. I just posted the Substack article I did about rings and knobs.
No, the Dupla company.
DUPPA. Dupa.net. I want to say
the lights I'm using are almost standard neopixels. So they don't, you send them a code and it displays the color that you asked for.
Oh.
So do they each have an address?
Yeah,
I
they each
didn't
have an
understand
address. They each have an address. But you don't. It talks standard neopixel though, so you just send them the byte codes that you want. So you send three bytes for RGB. That sorts itself out. So as far as you can tell from a programming point of view, they're just standard neopixels, but they're not. So I guess the big difference is that each neopixel receives all the code and it figures out which neopixel it is. So that means it all happens in parallel. So theoretically, it should be better if you have a lot of neopixels.
No, that's
So you're
very
not,
cool.
so
like how
it's not
big,
being
how's the
processed.
address space? What's the address space look like?
Well, you're just sending like a long string. So if you have if you've got 100 neopixels, you send 300 bytes of data telling it your RGB content for each LED.
Oh, and it passes on to the next one and strips it. Is that what
It
that
does in normal neopixels, but these are special neopixels for God knows why. It
Yeah,
surprised
sure.
me a bit because I just bought them off Amazon, and
No, I'm
then I
looking at it now.
realized
It's very interesting.
normally with neopixels, you just attach the strings. So if you have 100 neopixels here, this neopixel, the next string is pixel 100, and then it's 101, 102, 103, etc. So obviously this is 0 to 99 is here, and then this ends up being 100. But these addressable ones, you have 2 zeros. So this is pixel 0 and this is pixel 0. So if you want repeating neopixels, then that's great. But if you don't, then you have to use a multiplexer to get to solve that. So I'm just turning on different outputs here. So you're sending a 3-bit code here to switch between these different outputs, these 8 different outputs.
Richard, can I ask you about I think it's absolutely brilliant, that thing, and it would be great to have it online, maybe being served on a web server. Have you thought about doing that?
I have thought about that, but I'm looking for more interrupt-driven stuff. So what I thought was you can actually set up a Telegram bot. So Telegram bots are quite simple. And I thought, well, maybe I'll do that. So get the same Pi. If you register with the Telegram bot, you can just receive all the updates as they happen. Because really you want to know when something changes. So if there's a change in status is what you really care about. And maybe an hourly update or something like that, just saying it's still ongoing. But yeah, there's different options there. I mean, you can get the data itself off the TfL website. It's the same data, although I don't know how frequently they update it. Sometimes I detect a change before they do, before the website updates. So it's different.
It's really excellent. It's a very nice application. So yeah, congratulations.
Well, I think what people might also be like, if people may have their own ideas for dashboards, but this, I made it so you can hang it on the wall. So I don't know if you noticed that this picture here, for example, see the back of the picture frame. So of course, take the band out before you hang it. But yeah, you can see, you can sort of hang it on the wall, and it just adds the one power plug that you plug in, sort of a 5-volt. I don't know if you can see it. It's just down here. So it's quite discreet. So you can add it into the, hang it on your wall quite discreetly, and no one will know it's actually active until you turn it on. And because it's going through the paper, it's still a useful thing. So there's no holes drilled. It's just shining through the paper. So there's an additional bit of diffusion there to keep it from getting too bright. So it's just a normal tube lines map. But when you light the LEDs, you can actually get some status off it.
Curious, does it? So these are right behind the paper. And just curious, out of the heat generator, have you had issues with the paper yellowing, or do you have to pick out certain paper?
Not yet. They don't. They're just LEDs. They don't burn very hot.
Yeah.
They're quite bright, but I've never had any heat issues with neopixels. I don't know if anyone else has. I mean, it is.
I need to make a
right against
study.
the wood. They're right against 5mm wood, plywood, and then the paper's on top of the plywood.
So they're bright enough to use for lighting. If I want to put it under a desk for lighting, and then control the lighting based on time of day.
So if you see people have those LED strips behind their TVs and things like that, that's a common application for neopixels.
Any clue now that this is out? This is in a kiosk. It's got to go through weather issues. How will you handle? Like, how well is it working cold and warm?
I don't think it'll be an issue. I don't think it'll be a problem.
Yeah, I have a bunch of. So my house has LEDs, like Christmas lights all around, that are, awfully interesting. But I would love to. They burn out every now and then. and it takes out the whole chain. And what I like about these is that each one's individual. So if you burn one out, you don't lose the whole chain.
Yeah, if for example, yeah, I mean, it's shared power, so power runs all the way through as does ground.
That's fine.
So
That's
if you lose one neopixel, you sort of lose the rest of that chain. But yeah, it doesn't normally affect it. And you do lose neopixels every once in a while. They just sort of burn out or whatever, and all the other ones will still work as long as it doesn't affect the power.
So I got to look this up, but just curious again about the protocol. So what is there? There's 2 wires for power, and then there's another wire.
So there's
Is it
there's one. It's a 1-wire protocol with
right? Okay.
So in normal neopixels, data comes in 1 neopixel and goes out the other end of the neopixel to the next one, sort of serial. So if you buy neopixels off, if you just buy neopixels normally, you can just string them together. If you want 500 lights, you just put 500. Get
Oh, that's what the fast-led. That's what the fast-led protocol is for. I see.
Yeah,
very cool. I've seen this around. I'm so glad.
Yeah, they're really good. They're fun to play with. But I was more interested in them in being able to transmit data. What do you trying to show you information, useful information.
Well, that's it. That's exactly what it's for. It is a very quick, I look at it and I can tell what's going on without having to read something complicated. So tell me again a little more about what colors, like how do you choose your colors? What do they mean? What happens?
Yeah, so so the colors, you just so you do have to correct for it's called gamma correction. Mm-hmm. So you feed in a gamma correction string to allow for human perception of the light. So it's not, if you're asking for 50% light or 50% of the power output for red, for example, it's not necessarily 50% PWM or 50% pulse width. It depends on how people actually perceive it. So it just adjusts for all that physiology stuff. So it's quite good. It's quite a well-developed tool.
Yeah, the Dupa folks did that with their knobs and with their rings. They built gamma correction, and I was impressed. And like, I guess everyone's doing this now with LEDs. That's really cool. So, but I mean, like if I'm looking at that map, what is the map telling me? What are the different colors telling me? Do they just like, is there a warning?
So right now, for example.
Okay, so there's some white and there's some others.
So the white there, so the white is the northern line. Mm-hmm. So it's a particular line. So they have dedicated trains running that line. So there's 106 trains or something like that. And you can see the pink. The pink is the Hammersmith and City line, and it's flashing. Flashing slowly, so that means there's minor delays in that line.
That's what I was curious about. So that you've used flashing to indicate that, right?
Yeah, that's right. Or actually, that one's closed, so there's the suspension of some sort. And then you can see the red in the center is sort of going full on and then half off, and that's indicating major delays. So there's some sort of issue that is causing major delays. I do have to work on the animations a bit. You can do whatever you need to do, but this needs still a little bit of work. so it's very distinctive. I was thinking I could put a legend on there just so you know if it's flashing at this frequency or it's matching up with the same frequency, then you can tell what it means and things like that. But there's different. I guess you have to think about your own.
I understand. I just coincidentally, the reason I ask is I coincidentally just finished writing code for controlling the volume control, the ring around my volume control knob, and did some interesting animation with that. Whereas you turn the knob, it would follow, and then it would follow, and then it would sort of disappear. And so basically, you end up with a state machine that's triggered over time. And so these things are always fascinating. I'm imagining that one of my model railroad friends are going to ask me to come along and build something like this. Yeah, this is cool.
Yeah, it's just a bit of fun, really. But it